Hello children, welcome to another science lesson on electricity. To start today's lesson, I've got one of my favourite activities. It's zoom in, zoom out from Explorify here. So you've got a photograph on your screen and I want you to try and work out what that is a photograph of. Remember, we are zoomed in like we have a very powerful magnifying glass. What do you think this object is? Any ideas? I'm sure some of you have got some really great ideas. Okay, I'm going to zoom out a little bit to give you more of a clue. Now I bet loads of you know what this is. Here we go. Yes, children, can you see? It's a part of an electric light bulb. If I zoom back in, you'll see it's the bit here, okay, that we call this coil of wire, we call the filament. Can you say filament for me? It's the filament in the light bulb. The electricity passes through this filament and the filament then glows. It gets hot and it glows, and that's how we get the light from the light bulb, children. Okay, from that filament. But because that filament heats up as it glows, okay, sometimes the bulb can get hot too, so we should never touch a bulb that's lit. Okay, very important. Okay, that we leave any light bulbs that are lit alone. Okay, because they can, glass itself can get quite warm. Okay, so well done if you worked out that what you saw originally was part of a light bulb. Now, talking of light bulbs, children, last week you all managed to light up a light bulb in your work on electrical circuits and building your circuit for your lighthouses. You did an amazing job. So today we're continuing looking at electrical circuits. And the aim of today's lesson is for you to be able to predict, which is a very important science skill, and test, another extremely important science skill, complete and incomplete circuits. To be successful, you have to be able to identify what makes a complete circuit. I think you'll all be brilliant at that after building your circuits last week. You will have to be able to follow instructions to set up circuits and identify complete and incomplete circuits. So what makes a complete circuit? Every complete circuit must have a power supply. The power supply could be the mains or it could be a battery, just like the batteries in your circuits for your lighthouses. For a circuit to be complete, there must be wires connected to both the positive and negative ends of the power supply. So remember, children, on your battery you have a plus and a minus sign, and you joined a wire to the plus sign end of the battery and a wire to the negative end. When you completed your circuits last week, you used crocodile clips to attach, didn't you, that were on the ends of your wires. Electricity can only flow around a complete circuit that has no gaps. Very important, no gaps. So here we have a diagram of a complete circuit, very similar to the one that you completed last week, okay? And except, of course, your wires might be different colours. So why is this a complete circuit? Well, there's a power supply, the battery. Sometimes the batteries are known as cells, spelt C-E-L-L. So if you see that word connected with electricity, then you'll know it means a battery. There are no gaps anywhere. Look, no gaps. So the electrical current, the electricity, can flow around the entire circuit. Okay, so it can go from the battery round to the bulb, from the bulb back round to the battery in a complete circuit. The wires connect to both the positive and negative ends of the battery. So we have one wire at either end of our battery. That's what makes that circuit complete. What about this circuit? Well, this is definitely an incomplete circuit, and I think you can spot exactly why it's incomplete. The circuit is incomplete because there is a gap in the circuit and the electrical current cannot flow around it. Look, we've only got one wire going to the bulb, no wire coming from the bulb to the battery. The wires do not connect to the positive and negative ends of the power supply, okay, the battery. So it's very obvious that this is an incomplete circuit, children. You know what you'd need to add, don't you, to make it complete. So if you have access to a printer, I know some of you don't, there is a worksheet, this one here, attached to Tapestry today that you can print off. And if you do have the activity sheet, okay, you also need to get out your circuit that you're keeping safe for your lighthouse. On the activity sheet, you'll see pictures, diagrams, okay, of different circuits. 1, 2, 3, 4, 5 different diagrams. Firstly, you need to predict if you think the circuit will be complete or incomplete. And you can do that by giving a tick or a cross in this little square here, okay, in the bottom right-hand corner here on your sheet. So if you think that's a complete circuit, you'd give it a tick. If you don't think it is, you'll give it a cross. In that way, you're predicting. You're making a very sensible guess by looking carefully at the circuit. Next, you'll need to take the correct equipment, that's the equipment that's going to be used in your lighthouse, and test to see if your prediction was correct or incorrect. And lastly, you can record what you found out here on these lines. So was it complete or incomplete, and why? Okay, and don't forget to use the correct terminology when you are describing what happens. Okay, so you can use the word circuit, electrical current, flow, positive and negative in your writing. That would be amazing if you could do that. If you don't have access to a printer, okay, you can stay with me here on the video, and I've got a few diagrams for you to check out. Okay, so you'll have to pause the video after each picture and then test it out with your equipment. So complete or incomplete? Have a go at building that circuit. Pause the video, of course. Before you do so, you might want to predict. Complete or incomplete. Remember that prediction skill is really important before you rush off to test. So complete or incomplete for this picture. What about this one, children? Predict, complete or incomplete. Test. And then in your own words, can you explain why it's complete or incomplete? You might write down your answers, okay, with a little diagram in your exercise books for me. That would be brilliant if you could do that. Okay, and then once you've done the second one, there's one more for you here. Complete or incomplete? Predict, test, and explain. Predict. Is it complete or incomplete? Test using your electrical components that you've got at home, and explain why it is or isn't incomplete using scientific vocabulary. If we'd been in school, children, we might have replaced those bulbs with buzzers and motors. And I promise when you get back to school, we will definitely have a session where we get to explore buzzers and motors when we are back together again. Okay, so well done year 2. You now should be able to predict, test and explain how circuits can be complete and incomplete. And next week we will show you how to add your circuit to your finished lighthouse. I know you've still got to paint your lighthouses this week, hopefully. And so next week we will put everything together. Enjoy testing out those circuits. Okay, well done.